Right, intersection of lines. So sometimes when we draw lines, they intersect. For instance, I can draw this line and I can draw this line. These lines intersect at this point. Let's assume this point is P, right? This equation has y is equal to mx plus c, or maybe y1, right? This line also has an equation where these points meet is P. How can I find the point of intersection? How can I find the coordinate of this point? This is what we are learning right now. And then this is the method we use here is to solve the equations simultaneously. The idea behind it is if two lines meet, a point where they meet is on both of the lines. So that point P in this our case satisfies both this equation and this equation. So if we want to find a point that satisfies both equations, then we'll have to solve it simultaneously, right? So we'll solve them simultaneously and then we'll get just one point. So let's see. In example 1, we've been given two equations and then we've been asked to find a point where they meet. So let's see. In example 1, and these are the two equations. You should always make sure that before you solve the simultaneous equation, before you can solve equations simultaneously, they should be of the same form. Preferably this form, right? We should have the variables on one end and a constant term on another end, right? So in equation 2, we have this equation 1 and this is equation 2. In equation 2, equation 1 and equation 2. In equation 2, we have 5 on the left side. We have to move it to the right side. So let's do that. So we'll move it and then we'll end up with minus 5. So that becomes the new equation 2, right? So yeah, it's still equation 2, right? So this is equation 1 and this is equation 2. About to solve this equation simultaneously. To solve this simultaneously, we have two methods of solving. We have the substitution method, where we make either x or y, any of the variables, the subject in one equation, and then we substitute into the other equation. Or the elimination method, where we eliminate one variable. So I will use the elimination method in this example. To eliminate, you have to make sure we have the same thing on both equations. So I will try and make 2x here 6x, and then 3x here also 6x. So to do that, I'll multiply here by 3, multiply equation 2 by 2. After multiplying, I'll get 6x minus 9y is equal to 24. And that is equation 3. The next, equation 2, after multiplying by 2, the 2 multiplies to 6x plus 8y is equal to minus 10. That is equation 4. Plus 4y plus 8y, sorry, plus 8y is equal to minus 10. That's equation 4. Now how do I eliminate 6x here? If I subtract equation 3 from equation 4, right? So that would be 4 minus 3. That is equation 4 minus 3. So let's subtract equation 3 from equation 4, because 4 minus 3. So 6x minus 6x is 0, so it's gone, it's eliminated. 8x equals equation 4 minus this, that 8y plus 8y minus 9, right? So that will become plus, so that will be 17y is equal to minus 10 minus 24, that's minus 34. Y will be minus 2. Right, so I found y. How do I find x? To find x, I'll make x the subject in any of the equations here, right? So maybe equation 3 or equation 4 or any equation here. So I'll choose to make it the subject in equation 1. So from 1, making x the subject in equation 1 gives you 8 plus 3y over 2. Because 8 is here, 3y goes there, becomes positive, and then we'll divide by 2 in the end. Now I have to substitute this y value that I have in here. So 8 plus 3y, but y is 2, so let's put 2 in there. So 8 plus 6, wait, y is minus 2. So 8, this is minus 2. Oh. Minus 2. This 8 minus 6, right, over 2, that's 1. So in the end, the point of intersection becomes x value 1 and y value minus 2. So that's what we found. This is the point of intersection. It's very easy. It's just simultaneous equations. The only idea in here is to find the equation, the point of intersection of 2 points, and we need to solve them simultaneously. So in example 2, it's the same thing. We'll solve this equation and then this equation simultaneously to find the point of intersection. Right, so we want to find the point of intersection. So that's equation 2. We have x plus y minus 2 is equal to 0. That's equation 1. And then 2x minus y plus 5 is equal to 0. That's equation 2. But we need to send these to the other end because we need the constant terms to be on the right side and then the variables to be on the left side. So sending them there, so it becomes positive 2. That's equation 3. You can change the numbers as much as you want because it doesn't really affect your answer. I mean these numbers, the number of the equations. So I have equation 3 and equation 4. Right? I transformed equation 1 and equation 2 to equation 3 and equation 4. How do I eliminate a variable? Looking at my equation 3 and equation 4, I have plus y, I have minus y. That means if I add 3 and 4, I'll eliminate y. So I'll choose to add 3 and 4. If I add 3 and 4, I'll get 3x because x plus 2x, y minus y is 0 is equal to 2 plus minus 5, that's minus 3. So x is equal to minus 1. Now let's find y. How do we find y? Make y the subject in any of the equations. So I will choose to make it the subject in equation 1 or equation 2 or any of the equations. So from equation, right, let's make it the subject in equation 3. From equation 3, what is y? Y is equal to 2 minus x. So 2 minus x. X is minus 1 here. So minus 1. 2 plus 1. That is 3. That is 3. So y is 3. So the points of intersection. Oh, they didn't ask for point of intersection. The coordinate of A. So in this equation, in this example, it's A. The coordinate of A. So A is minus 1. Whoa. A is minus 1 and 3. Perfect. Minus 1, 3. And then we have the answer. So these are all examples in the same with the same concept to solve the equation simultaneously and have the answers. Thank you. So these are the equations. You can pause the video and solve them, or you could just solve them from the Acula Math textbook.